When a particle carrying a charge of 10 into 10 to the power minus 6 coulomb is brought from infinity to a point P, 2 into 10 to the power minus 3 joules of work is done. What is the potential at the point P? So there is a point called P in space, and a charged particle from infinity is brought to the point P. The work done to bring that charged particle was 2 into 10 to the power minus 3 joules, and the charge of the particle is given as 10 into 10 to the power minus 6 coulomb. So we have two informations in the question. The first information is the charge, that is Q, which is 10 into 10 to the power minus 6 coulomb. And then we have the work done, that is 2 into 10 to the power minus 3 joule. All the units are in SI unit. What we need to find out, what is the potential at the point P? So we need to find out the potential, that is denoted by V. So the formula that we can use here is, we have Q, W and V. So which formula contains all these elements? V equal to W by Q. So we can use this formula. Now if we put the values, V equal to in place of W we are writing 2 into 10 to the power minus 3, and in place of Q we are writing the value of Q 10 into 10 to the power minus 6. So in the next step, let us do one thing, let us break it. So 2 by 10 I am writing here, and multiply, we are separating the powers of tens. Okay, so we can do like this. Now let us first do this part. 2 divided by 10, it's just a simple fraction, we can cancel it. 2 times 1 is 2, 2 times 5 is 10. So in this case we can just write 1 by 5. Now let us do this part. For this part we can just use the laws of indices. We know if the bases are same, a, and the sign is division in between them, in that case a to the power m minus n. So here also the bases are same, 10 and 10. So we can just write it as 10 to the power minus 3 minus minus 6. Okay, so the power on the numerator is minus 3. Then we have minus for the formula, and then power in the denominator is minus 6. So now let us solve just this portion. Here minus 3, minus and minus becomes plus, and then 6. In the next part I am writing minus 3 and plus 6, so it becomes 3. Next, so our answer is V equal to 1 by 5 into 10 to the power 3. Now it's a fraction, it doesn't look good. So in physics we must give the answers in decimal. So to make this decimal, here 5 is the divisor and 1 is the dividend. So 5 is the divisor and 1 is the dividend. Now 5 times 0 is 0. We cannot go higher than that, because even 5 times 1 is 5, that is greater than 1. So after that we can write 1 here, and now it will go no more. So we will take a decimal point here, and we can take another 0 beside 1 for that. So 5 times 2 is 10, and it ends here. Okay, so what is the answer? Now instead of 1 by 5 we can write 0.2. 0.2 into 10 to the power 3, that is our answer. This answer is in unit volts, that is denoted as V. So finally there is the point P, and what is the potential at the point P? We can write the potential at the point P is 0.2 into 10 to the power 3 volts.